Scene script. Have you ever wondered about the world beneath your feet? Welcome to the intricate world of ants. This universe, invisible to the naked eye, is home to some of the most fascinating creatures on the planet. And, contrary to popular belief, there's more to these tiny beings than just their picnic-invading abilities. Imagine a society where every member has a specific role to play, from the queen to the workers to the soldiers. That's the world of ants for you. Their social structure is as complex and organized as any human society, and each ant has a job that contributes to the overall health and prosperity of the colony. Ever heard of the phrase, strong as an ant? Well, it's not just a saying. These tiny creatures can carry up to 50 times their own body weight. To put that into perspective, that's equivalent to a human lifting 2 compact cars. It's truly awe-inspiring that such small creatures can accomplish such Herculean feats. And while we're on the topic of strength, let's not forget about their diversity. The world is home to over 12,000 known species of ants. These range from the tiny pharaoh ants, barely a 1/16 of an inch long, to the giant forest ants that can grow up to 1.5 inches. And each species has its own unique characteristics and behaviors that make it stand out from the rest. From the deserts of Africa to the rainforests of South America, ants have made their mark in every corner of the globe. They have adapted and evolved to survive in a variety of environments, making them one of the most resilient creatures on Earth. And that's just scratching the surface of the microcosmos of ants. Let's delve deeper. Scene script. Have you ever seen ants moving in a line and wondered why? Welcome to the Ant Superhighway. In the bustling world of ants, communication is key, but how do these tiny creatures manage to navigate their complex societies and expansive territories? The answer lies in pheromones, chemical signals that ants use to chat with their comrades. Think of pheromones as the ants' version of a group text message or a social media update. When an ant finds a tasty morsel or a dangerous predator, it leaves a trail of pheromones for other ants to follow. It's a bit like dropping breadcrumbs to mark your path, or leaving a sticky note for your roommate to find the leftover pizza in the fridge. These pheromone trails form a network of roads, a superhighway, if you will, that helps ants navigate their world. They're not just wandering aimlessly. No, these critters are following the scent of success, be it food, safety, or a new place to call home. Now here's where it gets really interesting. The paths that ants take are not random, they're incredibly efficient. Ants instinctively know to take the shortest route, a behavior that scientists have likened to the algorithms used in computer science and logistics. In fact, the ant superhighway has been compared to the internet, another complex network that relies on efficient routing to deliver information. Some have even dubbed it the Anternet, a testament to the ants' impressive engineering skills. Ants don't just build their highways, they maintain them too. They clear away debris and repair any potholes, ensuring the path remains clear for their fellow ants. They're like a tiny, tireless road crew, working around the clock to keep their superhighway running smoothly. So, the next time you see a line of ants marching along, remember, they're not just following the crowd. They're using sophisticated chemical signals to communicate, navigate, and cooperate. They're following the scent of success on their very own superhighway. Who knew ants were natural-born engineers? But wait, there's more. Scene script. Ever considered the role of ants in our ecosystems? Let's explore. In the grand tapestry of life, ants, though petite, play an essential role. These tiny creatures are the unsung heroes of our ecosystems, contributing significantly to soil aeration, decomposition, and seed dispersal. Let's start with soil aeration. Ants are industrious diggers, excavating intricate tunnels and chambers in the ground. This relentless activity loosens the soil, increasing its porosity. This process of soil aeration enhances the soil's ability to absorb and retain water, nutrients, and oxygen, which are vital for plant growth and the health of the soil microbiome. Next, we have decomposition. Ants are nature's efficient waste managers. They break down organic matter, including dead insects, leaves, and other plant material, into smaller pieces. This process accelerates decomposition, converting the organic matter into nutrient-rich humus. This humus nourishes the soil, promoting the growth of plants, and in turn supporting the wider ecosystem. Ants also play a critical role in seed dispersal, a process known as myrmecochory. Many plant species rely on ants to carry their seeds away from the parent plant to new locations. The ants, attracted by the fatty outer layer of the seed, carry it back to their nest. Once the nutritious layer is consumed, the seed is discarded in the nutrient-rich waste pile of the ant nest, providing an ideal environment for germination. But the influence of ants extends beyond the soil. They impact other organisms and the environment. Ants prey on a wide range of pests, keeping their numbers in check. Their tunnels provide shelter for other small organisms. Moreover, their activities can influence the distribution of plant species and hence the landscape of an area. So the next time you see an ant scurrying about, remember the significant role these tiny creatures play in maintaining the health and balance of our ecosystems. Ants, the tiny but mighty stewards of our ecosystems, but their abilities extend beyond. Ants and symbiosis, a match made in nature. Let's unravel this relationship. When you think of ants, you might picture them scurrying about, working tirelessly to build their colonies. But there's more to these tiny creatures than meets the eye. They've mastered the art of symbiosis, forming beneficial relationships with other organisms in their environment. One fascinating example is the relationship between ants and aphids. Aphids are small insects that feed on plant sap, a process that produces a sweet byproduct known as honeydew. Now here's where it gets interesting. Ants love this honeydew. They farm aphids, protecting them from predators, and even moving them to better feeding grounds, all to ensure a steady supply of this sugary treat. In return, the aphids get bodyguards. It's nature's version of a win-win situation. But the symbiotic relationships of ants aren't limited to aphids. They also have a unique bond with caterpillars of certain butterfly species. These caterpillars produce a sweet substance that ants can't resist. Just like with aphids, the ants protect these caterpillars from predators, ensuring their survival. When the caterpillars transform into butterflies, they fly off, leaving the ants without their sugary reward. But don't feel too sorry for the ants. They've ensured the survival of their food source for another generation. These relationships are examples of mutualism, a type of symbiosis where both parties benefit. It's a fascinating aspect of ant behavior, revealing a complex world far beyond the simple image of ants as industrious workers. But mutualism isn't the only form of symbiosis in the ant world. There's also parasitism, where one organism benefits at the expense of the other. But let's save that for another time. Ants and their symbiotic relationships are a testament to the intricate and interdependent web of life that exists in nature. In the world of ants, it's all about give and take, but their world has a darker side too. Scene script. Did you know ants wage wars? Brace yourself for the battlefield. In the intricate world of ants, conflict is as much a part of life as collecting food and building colonies. Yes, ants, these tiny creatures we often overlook, engage in complex warfare, using strategies that might surprise you. Much like human armies, ant colonies have soldiers. These soldier ants are larger, stronger, and equipped with bigger jaws, primed for protection and defense. They stand guard at the entrances, patrol the perimeters, and when the colony is threatened, they charge into battle. They use their powerful mandibles not only to bite, but also to spray formic acid, an effective chemical weapon in the ant world. But ants don't just rely on brute force. They employ intricate strategies. Some species use stealth, sneaking into enemy colonies to steal larvae. Others use deception, releasing pheromones to cause confusion in the ranks of their foes. They're not just soldiers, they're spies and saboteurs. Now, let's delve into a rather controversial survival strategy, the concept of slave-making ants. Certain ant species, such as the Amazon ant, are known for this peculiar behavior. They raid neighboring colonies, capture their pupae, and bring them back to their own nest. When these pupae hatch, they are incorporated into the colony and perform all the labor, from foraging to caring for the queen's offspring. This strategy, while startling to us, is a testament to the lengths these creatures will go to ensure survival. Ant warfare is a spectacle of nature that is as brutal as it is fascinating. It's a testament to the complex social structures and survival strategies these tiny creatures have evolved over millions of years. In the world of ants, it's a constant battle for survival. And that concludes our journey into the fascinating world of ants.